Hey guys, so here's that video about how to use the unit circle to find sines and cosines of different angles. So, the first thing that we need to remember are the three standard angles. Now these are just the ones that are in the first quadrant, but we can use these to build the rest of the unit circle. And if you're a little foggy on how to do that, there's another video called Building the Unit Circle that you can watch, and that'll go over exactly how to count out all the angles on it. But so the smallest of the three standard angles is pi over 6, and then the next one is pi over 4. That's the one that cuts the quadrant in half angle-wise, and then pi over 3, which is twice the angle measure of pi over 6. And then the three numbers that we need to remember are 1/2, rad 2 over 2, and rad 3 over 2. Now, like I said, there's another video about where these numbers specifically come from, so I'm just going to go with it for now. So, the other thing that we have to remember is that sine is like the y-coordinate, and cosine is like the x-coordinate. So for any point on the unit circle, we can express it as cosine of whatever angle and sine of whatever angle. So for this point, if we draw a line segment, I guess, between the origin and that point on the unit circle, and then we look at this angle, sine of that angle will be the y-coordinate of this point, and cosine of that angle will be the x-coordinate of that point. So how far over it is and how far up it is. Okay. So, let's just focus on the first quadrant, because that's all we really need to get the idea for this. So here's our three angles. Remember that pi over 4 is the one that's kind of right in the middle, splits this quadrant in half, despite how I've drawn it poorly. And then pi over 6 is 1/3 of pi over 2, which is 90 degrees. So this is 1/3. This little slice here, the smallest one, is 1/3 of the quadrant. Then in between pi over 6 and pi over 3 is another third, and then the last third of the quadrant. Okay, and so what we want to do is look at the triangle that each one of these forms. So if we look at that tallest one, the pi over 3 triangle, it's got the largest, this point, when I talk about the triangle, I'm talking about this point, really. The largest y-coordinate, but the smallest x-coordinate. It's the tallest, but also the shortest. The thinnest, I guess. Then the pi over 4 triangle is the one that's right in the middle. Remember, it cuts the first quadrant in half. So I'm just calling it with a medium y and a medium x coordinate. And then that last one, the pi over 6 triangle, this one, the shortest one, has the smallest y-coordinate but the largest x-coordinate. It's the furthest over. Okay, so now for those three standard numbers, 1/2 was the smallest, rad 2 over 2 was the medium one, and rad 3 over 2 was the largest. So that's what we're going to use to assign sine and cosine values to each of these. So pi over 6 has the largest x-coordinate, so that means x, oh geez, I've labeled these backwards, sorry. This has the largest x-coordinate, so that's going to be rad 3 over 2. And it's got the smallest y-coordinate, so that's going to be 1/2. Then here, for pi over 4, they both have the medium x and medium y, so both of those are going to be rad 2 over 2. And then pi over 3 has the largest y, so its y-coordinate is going to be the largest number, and its x-coordinate is the smallest one. So here's cosine, and here's sine of each of those three standard angles. Now, also, it's worth mentioning that the sine and cosine of these two here, what is the cosine? The x-coordinate is the entire radius of the circle, so it's 1, and its height is 0. And here it's just the reverse. There's no movement on the x-axis, and it's another radius of the circle, but it's all y direction, so the coordinates at that point are 0, 1. Okay, so a couple quick examples. If we want cosine of 3 pi over 2, 3 pi over 2 is this guy right here. So we're talking about the x-coordinate, because we're talking about cosine, of this point. What's its x-coordinate? 0. So what about sine of 5 pi over 6? 5 pi over 6, of those 3 standard angles, is this one in the second quadrant. So sine is its y-coordinate. It's the shortest, so it's going to be 1/2. Tangent of 11 pi over 6. 11 pi over 6 is in the fourth quadrant, and of those 3, it's this one. And again, knowing which of these 3 these angles are will be something that is gone over in the building the unit circle video. So we want tangent, which is sine over cosine, so y-coordinate divided by x-coordinate. Well, the y-coordinate is the smallest one, but it's negative. Then the x-coordinate is the largest one, and it's in the positive direction. So this cancels out to negative 1 over rad 3, or we can rationalize the denominator and get that. And then sine of 5 pi over 4 is this. Wait, no, I'm sorry. It's this one. Of the 3 standard angles in the third quadrant, it's this one. And so sine is the y-coordinate. It's negative, and for the angles that have a 4 in the denominator, those are always rad 2 over 2, but it was negative. So this is how we use the unit circle to figure out what these values are, these sine, cosine, and tangent values are. And it works the same if we had secant, cosecant, or cotangent. We would just do this, but then flip them, take the reciprocal, because that's what secant, cosecant, and cotangent are. Okay, I hope this clears that up. I'll make another one with more in-depth examples of finding inverse trig function values for numbers.